Here we are with Math 3 Unit 2A, lesson and practice 2.3. So today we're going to be using the binomial theorem to help us out, okay? So in order to do that, we need to understand what that is and what it uses. And it uses Pascal's triangle, okay? So to remind ourselves, we've been talking about what happens when we have patterns here, okay? Like in this situation or in this situation, okay? And we found that there was certain rules that we could apply, right? That if we had this a plus b squared, we would get a squared plus 2ab plus b squared, okay? Now, Pascal's triangle in the binomial theorem comes about if we ask ourselves, well, what happens when we have one of those to a different power? So not just squared, what if it's cubed? What if it's to the fourth? What if it's to the fifth? Okay? Or so on and so forth, even higher. And we find out that there's actually more to these patterns, okay? And this mathematician, Pascal, he made a triangle, and I know it sounds weird to say it just like that, but basically what they did was they made a pattern of numbers, okay? So he started, let's go like this. He started like this. So the pattern starts like this. We have 1, then we take the numbers from the previous row to help us find the next ones. So this would be 1 and 1 as well. Okay, so the first and last term are always going to be 1s. Okay, and we make this basically like a pyramid. Okay, the way we get the numbers in between is by adding the 2 above. So that would be 2, this would be 3, this would be 3, this would be 4, 6, 4. Okay, so you can kind of see how the pattern's working. So, this Pascal just, discovered this pattern, and come to find out, it helps us out with the stuff we're dealing with. So 5, 10, 10, 5, 6, 15, 20, 15, 6. So you can kind of see that there's a pattern with these numbers, okay? So let's just at least go down to where we were at here. 21, 35, 35, 21, and 7. Then 8, 28, 56, 70, 56, 28, 8, and 1. Now, the way we read it is this is row 0. We start with 0, not 1. So then row 1, 2, 3, 4, 5, 6, 7, 8, and then you can just keep going on and on. Okay? And then terms, we refer to the terms like this. You want to call that the first term, we actually call that the 0 term. So that'd be 0, then 1, then 2. So 0 term, first term, second term, third term, fourth term, fifth term, sixth term. So if I wanted to say, well, what's the third term on row 7? Okay, so row 7 would bring me here. The third term, I'd go 0, 1, 2, 3. So it would be 35. Okay, now these numbers here, these numbers tell us coefficients. Okay, and a good one to use is looking at this first pattern that we've already dealt with. Okay, what are the coefficients of these terms? Well, for a squared, the coefficient is 1. For 2ab, the coefficient is 2. For b squared, the coefficient is 1. Okay, 1, 2, 1 is this set of coefficients, which if we look at this, that's the second row because it was a plus b squared. So the exponent tells you what row to use, then these numbers end up being the coefficients. So there's actually two parts to doing this. Okay, the first is the power tells the row. Okay, the power tells the row, and use Pascal's triangle to get the coefficients. Okay, that's the first part. Then there's one more part to it. Okay, so that's the first part, is that, like we said, with a plus b squared, that's one we've dealt with. Okay, that second row gave us the coefficients 1, 2, 1. Okay, the second part is the powers of the variables. And the way that works is the first term, the a term, and the power, you start with the power of the binomial goes to the first term, and then it works its way down. Okay, so let me show you an example. I'm not sure exactly how to write this down. So what I would start, it's 1a squared b to the 0. You have to use both of them. Then it's 2a to the first b to the first. Then it's a to the 0 b squared. So in other words, whatever power this is, whatever a is, you square it first. Then in the second term, you take it down by 1. So it's a to the first, because 2 minus 1 is 1. Then you take it down until you get to a is 0. And b, on the other hand, starts at 0 and goes up until it hits its number. Okay, and hopefully this pattern will become more apparent as I do some examples. So two parts to it. You have to know the coefficients, which, using the power and using Pascal's triangle, you're able to find. You then have to use these powers in the pattern of a starts at the highest, then goes down to the lowest, b starts at the lowest, and then goes up to the highest. Okay, so there's two aspects that we have to deal with. Okay, and that's when we're looking at problems like 3 and 4. Now, we have some notes here. Okay, and this is kind of that pattern that I was talking about, but I think it's difficult to understand in that sense. Another good one, this binomial theorem, actually looks like this, but it's extremely complex, so just use it the way I was talking about. And one way to see it is kind of right here. Okay, maybe this will help us with those powers. So anything to the 0, remember, is 1, which is the 0 row. Anything to the first is just a plus b, 1 and 1, right? 1a plus 1b, they're just to the first. Okay, then this one's the one we've dealt with, but now look at 3. See how a starts with 3, then 2, then 1, then 0, so it disappears. B starts with 0, so it disappears, then 1, then 2, then 3. If we looked at Pascal's triangle, its coefficients 1, 3, 3, 1. Coefficient of 1, of 3, and 1. Okay, so we'll take a look at how these work. Alright, so the first one just wants us to see how familiar we are with Pascal's triangle. So row 4, term 1. So let's actually use this one. I printed off one that's really big. So we've got row 0, 1, 2, 3, 4. How far did it want us to go? Row 4, term 1. Okay, so here's row 4. Then we start on the left side. Now remember, these first terms are always term 0. So 0, 1, 2, 3. So the third term would be 4 on row 4. Oh, term 1. Oops. So it's not 1, it's 4 again. So that's the coefficient. Okay, then 2 wants row 10, term 3. So row 10, term 3. So we go down to row 10, term 3. So 0, 1, 2, 3. So it'd be 120. Okay? And that's all it wanted us to do on that first part. Okay, now the second part we're actually going to have to expand it. Okay, 3 and 4. So, here's how we do it. Okay, when we're expanding the whole thing. So I first look at the power. It's 3, so that tells me we're on row 3. So let's get our coefficients first. Okay, which I'll just go to this one. Okay, we could also go to this one. So 1, 3, 3, 1. So 1 times something plus 3 times something plus 3 times something plus 1. Okay, those are our coefficients because we're making a polynomial essentially. You know, it's like we're saying negative 8x plus 4 times negative 8x plus 4 times negative 8x plus 4, right? That's what cubed means. So we'd have to use the area model for this, find that, then use that times this for the area model to get our thing. So with 3 it doesn't seem too bad, but believe me, it gets pretty complex. Okay, so now we need to figure out what is A and what is B. So A is negative 8x and B is 4. So the way the pattern works, since we have the third power, it'd be A to the third, B to the 0, then A squared, B to the first. See how A is going down by 1, B is going up by 1. You always start with the highest power at A and 0 for B. Then A to the first, B squared, and then A to the 0, B to the third. So see, each one gets, you know, A goes up, or A goes down powers, B goes up powers. From whatever R started out to 0, and it starts at 0 to whatever we end with. Okay, now, since I know what that should be, now I'm going to put this information in for A and B. So I get 1 times negative 8x cubed times 4 to the 0 plus 3 times negative 8x squared times 4 to the first plus 3 times negative 8x to the first times b squared plus 1 times negative 8x to the 0 times b cubed. Okay, then it just comes down to simplifying. So we need to figure out what's negative 8 cubed. Timesing by this 1, we can basically get rid of that, right? So if we get out our calculator and go negative 8 cubed, it is going to be negative 512 x cubed times 4 to the 0 is 1 plus negative 8 squared would be a positive 64, so 3 times 64 times x squared times 4. Okay, that's that term and this term. Okay, and I'm kind of running out of room, so I'm going to rewrite those ones just with more space. Okay, now we do this one. So 3 times negative 8 times x times 4 squared, which is 16, plus 1 times negative 8x to the 0 is 1, times 4 cubed, which is 64. Okay, then we just simplify the numbers. Negative 512 times 1, negative 512x cubed is our first term. 3 times 64 times 4, well, 3 times 4 would be 12. 12 times 64 would give us 768 x squared plus 3 times negative 8 would give us negative 24 times 16. So we get negative 384x plus 1 times 64 is 64. So that is our polynomial. If we take this and times it by itself 3 times, that's what we end up with. Now I know this looks very complex, but it's actually not as bad as trying to do it by hand. Okay, number 3, maybe you could have done it easier using the area model, but number 4 definitely wouldn't. And 5 and 6, I mean, look at how high those powers are. Okay, so let's try number 4 now. So once again, first thing we look at the power. It's 5. So I go over here to the 5th row. First thing I need is my coefficients. So 1, 5, 10, 10, 5, 1. So I know it's going to be 1 plus 5 plus 10 plus 10 plus 5 plus 1. Okay, apparently I need to give myself more room. So 1 plus 5 plus 10 plus 10 plus 5 plus 1. Okay, so those are going to be my coefficients. Now, a is 2x, b is y. So I start, it's going to be a, my highest was 5. So a starts at 5, b starts at 0. A goes down 1, b goes up 1. Notice that these two are going to always add together to be 5. Okay, so a down 1, b up 1. 3 plus 2 is 5. A down 1, b up 1. 2 plus 3 is 5. A down 1, b up 1. And you don't have to do it in this format with the a's and b's. You could already be plugging in your numbers. I'm just trying to show you the pattern. Okay, now I know that a to the 0 is 1, so I can basically get rid of that. Same with b to the 0. So really in the first term, all I need to focus on is a to the 5th. In the last, b to the 5th. Alright, so we can just reduce that one to a to the 5th and b to the 5th. So a would be 2x, so I'd go 2x to the 5th plus 5, 2x to the 4th. Now b is just y, so y to the 1st plus 10, 2x cubed, y squared plus 10 times 2x squared, y to the 3rd plus 5 times 2x to the 1st, so just 2x, times y to the 4th plus just b, because we can eliminate that, so y to the 5th. Alright, now we simplify. So 2 to the 5th, I believe that's 32. 2 to the 3rd would be 8 times 2 is 16 times 2, yeah. So that'd be 32 x to the 5th plus 2 to the 4th would be 16. 5 times 16 would give us 80, right? 0, 3, yeah. 80 x to the 4th, y, plus, that would give us 8. 2 cubed is 8. 8 times 10 would give us 80 again. X cubed, y squared, plus 2 squared is 4. 10 times 4 is 40. X squared, y cubed, plus 5 times 2 would give us 10x, y to the 4th, plus y to the 5th. And there's our polynomial for that one. Okay? So, pretty crazy, huh? But that pattern actually saves us a lot of time. Okay? Does save us a lot of time. Now, in 5, 6, and 7, they don't want us to do out the whole binomial. They just want us to find one of the terms. Okay? So the first thing we need to do is figure out what our coefficient is. So we're in the 9th row, term 7. So the 9th row, term 7, 0, 1, 2, 3, 4, 5, 6, 7. So it would be 36. Okay, so we're going to have 36. Then we got to think, okay, what's our A going to be? What's our B going to be? Now we can just simplify. So remember, it's 9th, so that would be A to the 9th. So A to the 8th, A to the 7th, to the 6th, to the 5th, to the 4th, to the 3rd. Okay, so you should have A squared. You could have worked backwards. I went, this is B to the 9th, B to the 8th, so B to the 7th, which B to the 7th would mean A would have to be squared because 2 plus 7 has to equal 9. So A squared, B to the 7th. So my A is 5x, so 36 times 5x squared. And then my B is 1, 1 to the 7th. Okay, 5 squared is 25, x squared times 36 times 1 to the 7th is 1. So 36 times 25 gives us 900, then x squared. So that's the 7th term of that one. Okay. Now number 6, this time we want to go to the 12th term, or term 3 of the 12th row. So we go back to ours. Oops. So we need to go down to the 12th, and we wanted the 3rd term. So 0, 1, 2, 3. So it's 220, right? And then what is our A and B going to be? Well, A would be right here would be to the 12th, so 11, 10, 9. So a to the 9th, which means b has to be to the 3rd, because 9 plus 3 has to equal 12. So 220, a to the 9th, b to the 3rd. So a is negative x, so 220 times negative x to the 9th times negative 2y to the 3rd. So negative x to the 9th would still be negative, so we have negative 220 x to the 9th times negative 2 to the 3rd would be negative 8 y to the 3rd. So negative and a negative make a positive, so 220 times 8, and we'd have x to the 9th y to the 3rd. So whatever 220 times 8 is, which is, and that gives us 1760, 220 times 8. So our answer, that is the 3rd term in that binomial if we expanded it out. Okay, hopefully you get the gist of it. So now looking at this one to the 14th, and they want term 13. Okay, so we need to go down to row 14. Oops. Row 14, and we wanted the 13th term, right? Yep. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so our number would be 14. That's our coefficient, 14. Then, being right here, this would be b to the 0, so it's going to be b to, or not b to the 0, b to the 14th. So you're going to have b to the 13th, which means a to the 1st. So 14, a to the 1st, b to the 13th. So we've got 4x, so 14 times 4x to the 1st, because that's a, and then y to the 13th for b. So this one doesn't end up being too bad. So we have 14 times 4x, y to the 13th. So 14 times 4 would give us 56. So 56x, y to the 13th would be the 13th term here. Alright, now we can also use this stuff to deal with probability here. Okay, like this one. Tamara is choosing cities to visit on her train trip across Europe. For problems 8 through 10, use Pascal's triangle and given numbers to determine the number of different combinations. Okay, so when we're dealing with those combinations, how many different ways we can organize something. Pascal's triangle actually works for that too. It's really useful. So in other words, we've got 15 stops here on the train, right? Driving the train here. And we want to know the combination of 3, 5, and 8 cities. So there's 15 total. So the total is like your row. So we're going to go to row 15, and then we're going to do term 3, 5, and 8. Okay? So if we go down to row 15, that would be 0, 1, 2, 3. So that's how many combinations there are. For 3 cities, you can go to 455 combinations. Okay, what about for 5 cities? Well, that was 3, 4, 5. For 5 cities, there's 3,003 different combinations. So what that means is there's 3,003 different ways I can organize 5 of these cities to be stopped to. Okay? Then the last one, what if we went to 8? So 6, 7, 8. 8 would be 6,435. So when we're dealing with those combinations, we can also use those, use Pascal's triangle to help us find those kind of combinations. Oh, there we go, guys.